Hi everyone, it's Ms. Haley again. In today's video, I'm continuing on the section 11.1 notes, just expanding on the ideas that we learned about in the last video on basic trigonometry, kind of expanding on and including some more difficult examples, so more problems, things like that. So let's go ahead and get started. Again, this is going to be different than what you see in your checkup and in your study guide. I wanted to pull examples from those, but add a little bit more that'll directly relate to what you'll see on your quiz this week. So it'll probably help you a little bit more than if I went through the entire checkup and in the entire study guide. So here's one example from the checkup from this week. So we're finding trig ratios. So let's write down our little acronym. So TOA. Remember that stands for sine, cosine, and tangent, and which sides those used for those ratios. And then remember that cosecant, secant, and cotangent are the reciprocal trig ratios of sine, cosine, and tangent. Alright, so first we want to find the sine of x and the cosecant of y. If you notice, we have this side and this side, we have both of those lengths, but we don't have the length of the hypotenuse here. So if we have two lengths of a right triangle and we want to find the third side length, we can use the Pythagorean theorem to find that missing side. So I'm going to go ahead and do that. 5 squared plus 7 squared is equal to x squared. And remember, Pythagorean theorem can only be used with right triangle, right? So 25 plus 49 is equal to x squared. 25 plus 49 is 74. So if I want to get x by itself, I have to take the square root of both sides. So x, or our missing side, is equal to the square root of 74. So now we have both, or all three side lengths, so we can go on and find the different trig ratios now that we have all the information we need. So let's first find the sine of x. Alright, so here's our angle S, our x. Remember that sine is the ratio of opposite divided by hypotenuse, so the opposite side to angle x would be 5, and then the hypotenuse is square root of 74. Typically, we do not write we do not leave our answers like this, but I believe in your quiz they do. So I'm not going to get too in-depth with that. That's fine for now. I think in pre-calc next year you will learn how to what's called rationalize those fractions. You're not typically supposed to leave a square in the denominator. We'll leave it like that for now. Okay? Cosecant of y. Alright, remember that the cosecant is the reciprocal of sine. So instead of opposite over hypotenuse, is going to be hypotenuse over opposite. So in respect to y, hypotenuse is the square root of 74. Oops. And then the opposite side of angle y is 7. All right, perfect. So we just got through the first example. Let's move on to the second. First, we want to find the tangent of x. Tangent is opposite over adjacent, so if we're looking at angle x, the opposite side is 5, and then the adjacent side is 7. Now I want to find the cotangent of y, which instead of opposite over adjacent, it's going to be adjacent over opposite, since it's the reciprocal. Adjacent is going to be 5, and then opposite is going to be 7. So in that case, those two end up the exact same. Adjacent over opposite. Now let's go ahead and do our third and final example on this problem. We're going to find the cosine of x. Remember, cosine is adjacent over hypotenuse. So if we're looking at x, adjacent is 7. Hypotenuse is square root of 74. Now if I want to find the secant of y, that's the reciprocal of cosine. So instead of adjacent over hypotenuse, it will be hypotenuse over adjacent. So that's square root of 74 over 5. All right, so hopefully that made sense. That's kind of just using what we learned from last week, or I'm sorry, from the previous lesson this week. So let's go ahead and move on to something a little bit more complicated. All right, so let's find the measure of angle B. So it looks like we have the measure of angle C. Remember, when we have that box, that means it's 90 degrees. measure of angle A looks like it's 75 degrees because they gave it to us, so we want to find the measure of angle B. If you remember from geometry, all the angles in a triangle add up to 180. Alright, so if I want to find B, I just take 180 and subtract 90, and then subtract 75. So that's 180 minus 165. So that means angle B is 15 degrees. Alright, so now that we have all three angles, let's go ahead and find some side lengths. Alright, so we want to find x. So first you have to pick, am I going to be using 75 as my angle or 15 as my angle? Because remember, depending on which angle you're looking at, changes which sides are opposite and adjacent, right? Let's say that I want to use 15 as my angle. Let's say that B is my angle that I want to use. If I want to find x, let's label our triangle accordingly. Y is going to be the opposite side from 15. X is going to be our hypotenuse since it's across from the right angle, and then that leaves 125 as our adjacent. Alright, so if I want to find x, that's our hypotenuse. So looking at SOHCAHTOA, my only options for finding something with the hypotenuse in it are sine and cosine. Tangent has nothing to do with the hypotenuse. But if I look at the opposite side, I don't have a value for y, right? I don't have a value for my opposite side. So in that case, I'm going to have to use cosine in order to find x, because I need at least one of those measures in order to find another one. I can only have one missing measure, okay? So the cosine of my angle, in this case we have an angle that's 15. So cosine of my angle, 15 degrees, is equal to adjacent, which is 125, divided by hypotenuse, which is x. So you can see if we decided to use sine, we would have had two missing pieces of information, right? We would have had y over x, and that wouldn't have been easy to solve. So we used cosine so that we only had one piece of missing information. So at this point, our goal is to get x by itself so we can figure out how long it is. So how do I get x out of the denominator? Multiply both sides by x. So now I have x times cosine of 15 is equal to 125. Now how do I get the x by itself? I'm going to divide both sides by cosine of 15. So if I divide both sides by cosine of 15, on the left side I just have x, and on the right side I have 125 divided by the cosine of 15 degrees. Now, looking at that answer, we got x by itself. It looks like it'll be an answer, right? But we don't actually have an idea of what that is in our minds. So because you guys probably don't have graphing calculators at home, I want you to go to the Desmos scientific calculator. You can get that on your phone. You can probably get an app for a graphing calculator. You can even do this using the iPhone calculator if you kind of turn it horizontally. It's not super easy to use. So I recommend going to the Desmos scientific calculator because you can see down here on the left side we have sine, cosine, and tangent, and we can calculate those values. So looking back, we want to do 125 divided by the cosine of 15 degrees. So 125 divided by the cosine of 15 degrees, close that parenthesis, and my answer shows up on the right side. That's 129.4, let's say. So x is going to be 129.4, or you could see 0.41. I don't remember what it said to round to. So I hope that made sense. Let's go ahead and do one more. We want to find the length of y now. Okay. Let's do red. Okay. So if I want to find the length of y, again, I'm going to be using b as my angle, 15 as my angle. So y is my opposite side, so I know I'm going to either have to use sine or tangent. Those are the only ones that deal with opposite. And I know I need at least one piece of information. So do I have a value for a or do I have a value for h? Now I do have a value for h, but typically we use the value that's already given to us. So that would be a, right? We already have 125. That's a solid value that's given to us. So I think it's best to use tangent. Okay. So if we want to find tangent, let's do tangent of our angle. We're using 15 degrees as our angle, is equal to opposite over adjacent. Y is the opposite, adjacent is 125, so there's our equation. So now our job is to get y by itself, so we can plug it into that calculator and get our final answer. So how do I get 125 over to the other side? Multiply both sides by 125. That cancels that out. So I have 125 times tangent of 15 is equal to y. And now I have y by itself, so all I have to do is plug this into my scientific calculator. So 125 times the tangent of 15. So let me clear this out. 125 times the tangent of 15. And that gave me 33. Oops, I don't know why I did that. 33.5 for my answer. 33.5. That's the length of y in our triangle. All right, so hopefully that made sense. I think this might be something on your quiz. I know this is pretty complicated, especially for your first time looking at it. Just try your best, and if you have any questions on this, I would be more than happy to help you with it. I know it's a lot. All right, here's a word problem, and I think this is something you'll definitely see on your quiz, so this is something you'll really want to practice, really get a good handle on before your quiz. Make sure if you are taking notes on this, you have this with you while you're taking your quiz, so you can kind of reference it. So this is an example actually from the checkup. So if you've already done the checkup, this is a good way to check your answer as well. A surveyor measures the angle of elevation at 20 degrees for a point 5 miles away. What is the vertical change in elevation from the point where the surveyor is standing to the point 5 miles away? So I think what the best thing to do in these types of situations is to draw a picture. So there's my surveyor. It says he's looking at a point 5 miles away. So horizontal line 5 miles away. All right, we want to find the vertical change in elevation, right? We want to find that area. And he said that the angle that he's looking at is 20 degrees. All right, 20 degrees right in this little angle right here. And then this is a right angle, right? So we want to find the vertical change. So I'm going to mark that as x. So if you see, we basically just drew a right triangle, and we have two pieces of information, and we're missing one piece of information. That's perfect for a trig problem. So here's my angle. X is going to be my opposite side. Here's my hypotenuse. I don't have a value for that, so we can ignore it. And then here, 5 miles is my adjacent side. So if I'm using O and A, which trig ratio should I use? Tangent, right? So I can write an equation. Tangent of 20 degrees is equal to opposite over adjacent, so x over 5. Now I just have to get x by itself, plug it in the calculator. So multiply both sides by 5. So 5 tangent of 20 is equal to x. So that's what I'm going to plug in my calculator. 5 tangent of 20. Oops. Go back. 20 close parentheses. So 1.82 or 1.8. 1.8, in this case it would be miles. So I think drawing the picture is probably the biggest challenge. If you can go from the words into kind of a physical picture, that really makes the equation easy to set up. So that's something you should definitely be practicing when you're doing these word problems. All right, and then the last thing I want to go over is exact trig values. So for 30 degrees, 45 degrees, and 60 degrees, you can always calculate the exact trig values. So in our previous example, we were taking the tangent of 20 degrees. That's not an exact value that I can do in my head, or that it's something that needs to be approximated using a calculator, so that's why I had to use my calculator. If I'm taking the sine, cosine, tangent, or the reciprocal of trig functions of 30 degrees, 45 degrees, or 60 degrees, those are actual exact values that we can write as fractions and as square roots. And so this is a chart that you're going to want to copy down and have with you during your quiz in case it asks you, like, what's the sine of 30 degrees? If you just look at this chart, you'll have it. Move on to the next question. So I could go into special right triangles and why these values are the way they are, but I think for now it would be best if you just have this and maybe wait until pre-calc to fully understand it, because it is kind of a more complicated way of finding these. So the sine of 30 degrees is 1/2. So that means that the cosecant of 30 degrees is 2 because that's the reciprocal. The cosine of 30 degrees is square root of 3 over 2. So the secant is going to be the reciprocal. So you'll either see it as 2 over square root of 3 or 2 square root of 3 over 3. You'll see it either way. And then the tangent of 30 degrees is 1 over square root of 3, or you'll see it as square root of 3 over 3. So that means that the cotangent is just square root of 3. All right, so I know my handwriting's not the best, but hopefully if you're listening along, that'll help you. The sine of 45 degrees is either 1 over square root of 2 or square root of 2 over 2. And when I write or, those are really the same number, but it's just a matter of rationalizing the denominator, which, again, I don't want to get into and make these videos an hour long. So typically, you'll see the version on the right side, the second version that I'm writing, but Apex might have taught you in the first version. I'm not really sure. The cosine is going to be the same thing, actually, for 45 degrees. So 1 over square root of 2 or square root of 2 over 2. And then the tangent is 1. The tangent of 45 degrees is 1. So then if we look at the cosecant and the secant, that's just going to be square root of 2, looking at the reciprocals, and then the cotangent of 45 degrees is 1 as well. Alright, moving on, now we're going to be doing 60 degrees. The sine of 60 degrees is square root of 3 over 2, so that means the cosecant is either 2 over square root of 3, or you could see it as 2 square root of 3 over 3. The cosine of 60 degrees is 1/2, so that means the secant of 60 degrees is just 2. And then the tangent of 60 degrees is square root of 3. So that means that the cotangent of 60 degrees is either 1 over square root of 3 or square root of 3 over 3. So again, this is something you're going to want to write down. This is probably something you saw in Apex, but I just want to bring it to your attention that this is something that I'm pretty sure that they're going to ask on your quiz. So make sure you have this with you. Make sure you have your other notes with you as well to help you along. So that's actually, that's it for this video today. So I hope you have a great day. I hope this helps. And make sure to reach out on Teams or with email if you have any questions, and make sure you're getting all of your quizzes done, all of your Teams work done, and keep working hard. All right, talk to you all later.